All right, greetings scholars, greetings YouTube. We're here for our next installment for chapter 3 from College Algebra. This is from Blitzer, Thinking Mathematically, chapter 3 on logic. And so we're working on section 3.5, equivalent statements and variation of conditional statements. A few objectives here. 1, we like to use a truth table to show that statements are equivalent. 2, write the contrapositive for a conditional statement. 3, we like to write the converse and inverse of a conditional statement. Equivalent statements. Equivalent compound statements are made up of the same simple statements and have the same corresponding truth values for all true-false combinations of these simple statements. If a compound statement is true, then its equivalent statement must also be true. If a compound statement is false, its equivalent statement must also be false. Okay, I feel like that's straightforward. So an example showing that statements are equivalent. Show that P or not Q and not P implies not Q are equivalent. Okay, so what we're going to do is construct a truth table for both of these compound statements and show that their final truth columns are the same. Right? So let's start off with some graph paper. All right, so in either case, it looks like we have two simple statements. So we're going to need 2 to the power of 2 rows. Long story short, we're going to need 4 rows altogether. So we have P versus Q. Okay. Let's see. Copy. It move? Oh no, I hope it didn't move. It's gonna throw my stuff off. Let me see, maybe. I think it did move, but we'll just go with it. Okay, so then to fill in the rows, the first column we do half and half, so half true and then half false. And then since that went by 2s, the next column goes by 1, so it goes true, false, true, false. Okay. All right. So we're going to compare P or not Q. And yeah, I'll do it like that. We're going to compare that with not P implies not Q. Not P implies not Q. Okay. All right, so if we're working with the first compound statement, the dominant symbol is the disjunction, the or. So that means we do the not Q first. So I'll put that result, I'll put it like right here. And again, this is our column 1, this is our column 2. Okay, so not Q is going to be the opposite of Q. So then it's just false, true, false, true. That's our column 3. So then we want to say P or not Q. So we're going to say column 1 or column 3. So or is true when at least 1 is true. So we already know off the bat that this is true and this is true. And then between 1 and 3 is at least 1 true? Yes. And then on that third row is at least 1 true? No. Okay, so this is our final column here. And I'm going to highlight it like this. Let's go about like that. Okay, so then let's do the truth table for this second compound statement. Let's do this not P first. So the opposite of P, false, false, true, true. That's our column 5. Let's do the opposite of Q. Let's do the not Q. So false, true, false, true. That's our column 6. Okay. And then now we want to say column 5 implies column 6. So implication is always true except true implies false. So false implies anything is true. False implies anything is true. True implies false is false. True implies true is true. Okay. Let's just copy and paste. Okay. And so then notice that the two final truth columns are the same. True, true, false, true. Okay, you see it here. Oh, this is a fairly short section. Okay. So then variations of the conditional statement P implies Q. A conditional statement and its equivalent contrapositive. P implies Q is equivalent to not Q implies not P. The truth value of a conditional statement does not change if the antecedent and contrapositive are reversed and both negated. The statement not Q implies not P is called the contrapositive of the conditional statement P implies Q. So here we're asked to write the equivalent contrapositive for, if you live in Los Angeles, then you live in California. We're going to let P be you live in Los Angeles. We're going to let Q be you live in California, right? Okay. So if we just do a direct translation of this sentence into symbolic form, this is just going to be P implies Q. But then if we want the contrapositive, that should be logically equivalent to not Q implies not P. Can't get my writing together today. Not Q implies not P, right? So then if we apply that back to the sentence, if you don't live in California, then you don't live in Los Angeles, right? I'm not going to write that out. I think you can do that. Again, if you don't live in California, then you don't live in Los Angeles, right? So, see, there it is. Okay, if you do not live in California, then you do not live in Los Angeles. Okay. So some other variations of the conditional statement. So, the conditional statement is P implies Q. If P, then Q. The converse, all right? So let me see. Conditional and contrapositive are equal. Converse and inverse are equal. Conditional and contrapositive are equivalent. Converse and inverse are equivalent. Yeah, that's what I was looking for. Okay. So the converse is Q implies P. That's if Q, then P. The inverse is the contrapositive of the converse. So that's not P implies not Q. And then the contrapositive is not Q implies not P. But again, the main takeaway here is that we have to be aware that the conditional and the contrapositive are equivalent, and then the converse and the inverse are equivalent. Okay. Write the converse, inverse, and contrapositive of the following conditional statement. Okay, so before we tackle this one, I think I'd like to just make a chart of what we just experienced, right? So the conditional that's just going to be our P implies Q. And then the converse, which is not necessarily equal to the conditional, is going to be Q implies P. And then the inverse, which is equivalent to the converse, is the contrapositive of the converse. That's going to be not P implies not Q. And then lastly is the contrapositive. That's going to be not Q implies not P. Okay. Let's see. If you are 17, then you are not eligible to vote. Okay. So it looks like we're going to let P be what? You are 17. We're going to let Q be, it looks like it should be you. Should we say you are eligible to vote? Or you are not eligible to vote? That's the only thing. Let me see. Because it just depends on how you set it up. Okay, let's say that Q is you are not eligible to vote. I feel like that's going to be a little bit confusing. Let me see. I'm just going to look and see real quick. You are not, let me see. You are eligible to vote. Okay, that's better. Okay. So you are eligible to vote. Okay. So then the conditional, oh, I'm not writing all this out. So, okay, I guess we can do it in symbolic form. If then, so for the conditional, in this case, let's do this in a different color since we're answering the question. And actually, I kind of want to move this stuff around. Give me just a moment. I'm going to move this down some. And I want to move these side by side. So there's a P. Let's undo. Here's our Q. And then, oh. Okay, and we'll do our result. I want a dark green. Okay, so the conditional, we're going to say what P implies not Q. So the conditional of this in symbolic form is going to be P implies not Q. Now they're asking for the converse, inverse, and contrapositive. So if the conditional is P implies not Q, then the converse is going to be not Q implies P. Not Q implies P, all right? So then that would be, if you are not eligible to vote, then you are not 17. That's not necessarily true because there are people that are over 17 that can't vote, right? Like ex-cons and, or non-citizens, people like that, so. But again, the converse does not necessarily have the same truth value as the conditional. The inverse is going to be not P implies not Q, but then the double negative becomes positive. So the inverse is going to be not P implies Q. So then that's going to be, if you are not 17, then you are eligible to vote, all right? Which is not true, right? And then the contrapositive is going to be not Q implies not P. In other words, Q implies not P. All right. So that would be, if you are eligible. Oh, did you stop my recording? Oh, I hope it didn't mess up. I'm going to assume that it's working. I still see my record button, so I'm just going to go with it. And I'll have to check it later. Let me see. If you are eligible to vote, then you are not 17, which is true, right? Okay. So I didn't write out this indices, but we have them here, and I think we're okay. Okay. So I'm going to let that be. And here are the results here. Right. So we said that the converse and inverse were not necessarily true, but then the conditional and contrapositive are true. Okay, that wasn't too terribly bad. Oh, and they kind of conked out on me at the last second, but I think we're okay. We're going to go with it. Okay, so on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care, guys. Peace.